Look at the photograph. It was taken in the early 1880s, deep inside a newly blasted tunnel somewhere in the American West. The image is scratched, sepia-toned, captured on a fragile glass plate negative by a photographer who had to drag a heavy wooden camera and volatile magnesium flash powder hundreds of feet into the dark. In the foreground, you see a crew of men. They are wearing bowler hats, heavy suspenders, and thick boots covered in a fine layer of pale dust. Some are leaning on wooden handles. Some are staring blankly into the lens, their faces blurred into ghosts by the long exposure time required in the dim light. If you read the caption provided by the Historical Society, it tells a very simple, familiar story. It says these men carved a 2-mile hole through solid mountain rock using pickaxes, shovels, and brute force. That is the official history. It is the story printed in the textbooks, the story written in the railroad ledgers, and the story we have all passively accepted. But I want you to look past the men. Look at the wall of rock behind them. The stone is granite. It is one of the hardest natural substances on Earth. And yet, the walls of this tunnel curve with a terrifying precision. If you look closely at the raw rock face, you do not see the chaotic, jagged splintering of men wildly swinging pickaxes. You see a rhythmic, geometric pattern of perfectly parallel grooves, descending in exact increments, sheared off in massive, uniform sheets. The ceiling arches flawlessly, holding back millions of tons of crushing geological pressure without a single steel support beam in sight. When modern engineers look at this photograph, or when they walk through these surviving tunnels today, they are faced with a profound physical contradiction. Iron pickaxes and shovels simply bounce off solid granite. They dull, they spark, and they shatter. Brute force does not carve perfect acoustic vaults through the roots of a mountain range. The official record tells us this was unskilled manual labor, but the stone itself tells us that what happened in the dark was an exercise in absolute mathematical precision. So, what are we actually looking at? How did a crew of men in the 1880s cut through miles of solid rock at a pace that we would struggle to match today without massive diesel-powered boring machines? And why does the physical evidence left in the stone seem to describe a level of technological sophistication that the official history books completely ignore? We're going to look at what the railroad ledgers actually say, at the hidden details in the vintage photographs, at the physical mechanics of the rock itself, and at the forgotten genius of the people who held the tools. Because the answer is not about secret machines or hidden steam engines. It is about a profoundly advanced form of human knowledge that built the modern world and was then quietly allowed to vanish. If you enjoy stories the history books quietly skipped, consider subscribing because this channel lives on them. To understand the sheer impossibility of what you are looking at in that photograph, you first have to understand what these men did not have. It is the late 19th century. The great railroad barons are in a desperate, ruthless race to lay tracks from coast to coast, cutting through the Sierra Nevada, the Rockies, and the Appalachians. The men organizing this expansion are sitting in comfortable offices in New York, London, or San Francisco. They view the mountains merely as lines on a map, obstacles that cost time and money. But for the men on the ground, a mountain is not a line on a map. It is a solid, three-dimensional nightmare of igneous rock, underground rivers, and toxic dust. In this era, the pneumatic drill, powered by compressed air, was in its absolute infancy. A few heavy, cumbersome prototypes existed, but they were vastly expensive, constantly breaking down, and practically impossible to drag up the sheer cliff faces of a remote mountain pass. Modern, stabilized dynamite was barely entering widespread use, and in many remote camps, it was considered too expensive or too unpredictable. The primary tools issued to these camps were exactly what the ledgers say they were: hand-forged iron tools, wooden handles, wheelbarrows, and black powder. That is the inventory listed in the surviving supply manifests from the 1870s and 1880s. 500 shovels, 2,000 pounds of iron rod, 50 barrels of powder. When you read the diaries of the surveyors and the foremen, the language they use to describe the laborers is almost universally dismissive. The ledgers refer to them simply as hands or units of labor. They were Irish immigrants fleeing famine, Chinese immigrants seeking a foothold, Cornish miners who had spent generations in the dark, and men with no names trying to outrun their pasts. The official narrative framed them as an unthinking mass of muscle, swung like a blunt instrument against the rock until the rock gave way. The foreman wrote reports boasting of how many linear feet they had advanced in a week, attributing the success to their own strict management and the sheer sweat of their interchangeable workers. This is the narrative that cemented itself in history: unskilled labor, primitive tools, brute force. But hold on to that official narrative, because when we step out of the archives and look at the physical evidence left behind at the sites, a completely different reality emerges. Decades later, geological engineers and industrial archaeologists began to formally survey these abandoned railway tunnels. They walked into the dark with high-powered flashlights and measuring equipment, mapping the exact dimensions of the cuts. And what they recorded should not have matched the primitive inventory lists of the 1880s. Here is the part that makes the official story so hard to accept. When you study the walls of a tunnel cut through pure basalt or granite, you can read the sequence of its destruction almost like the rings of a tree. The archaeologists found that the rock had not been chipped away in small, desperate chunks by men swinging picks. A pickaxe leaves a very specific, chaotic fracture pattern. It shatters the surface in shallow, irregular spiderwebs. But the walls of these tunnels were dominated by smooth, sheared faces, sometimes dropping 10 or 15 feet at a time, completely flat. Along the edges of these massive shear drops were lines of perfectly spaced half-cylinder grooves, running parallel to each other, exactly 3/4 of an inch wide and sometimes 3 feet deep. Look at what this means. To create one of those half-cylinder grooves, a perfectly straight, perfectly round hole had to be drilled 3 feet deep into the hardest rock on Earth. Now look at the math. A tunnel that is 20 feet wide and 20 feet high, advancing just 10 feet into the mountain, would require hundreds of these precise holes to be drilled in a specific geometric pattern. The official record says this was done without machines. But anyone who has ever tried to drive a steel peg into solid granite knows that after 5 minutes, your arms are dead, the peg is dull, and you have barely scratched the surface. To drill hundreds of 3-foot deep holes, perfectly aligned, in the suffocating black powder smoke of an unventilated tunnel, day after day, year after year, defies the biological limits of what we consider possible for unskilled labor. And the contradictions do not stop there. The archaeological surveys revealed that the shape of the tunnel was not a rough, jagged cave. It was a calculated ellipse. The roof was arched at a specific mathematical gradient, designed to transfer the immense weight of the mountain down into the side walls. If the arch was too flat, the ceiling would collapse. If the walls were too steep, the pressure would push them inward. The men in the dark were not just digging. They were carving a structural masterpiece that required a deep, almost instinctual understanding of geological load distribution. Every time modern investigators tried to reconcile the physical evidence with the official story, the gap widened. The ledgers said simple brute force. The stone said highly coordinated, precise engineering. And no one could explain how an army of supposedly unskilled men with iron rods could achieve the dimensional tolerances of a machine. This is the moment the whole case turns. Because if the physical evidence is true, then the official explanation is not just incomplete, it is actively hiding the reality of what happened. For years, alternative theorists have looked at these perfectly sheared walls and these impossible timelines and jumped to the most sensational conclusions. They argue that the railroad companies must have possessed advanced secret technology, perhaps massive steam-powered boring machines that were covered up, perhaps some lost mechanical device that history intentionally suppressed. They argue that the men in the photographs were just a front, posing with hand tools for the cameras while a hidden machine did the real work. But there is a fatal flaw in the secret machine theory. If there were massive steam-powered boring machines in the 1880s, where did the coal come from to run them? Where are the exhaust vents for the deadly carbon monoxide? Where are the shipping manifests for the heavy iron replacement parts? The mountains were completely isolated, accessible only by pack mules on narrow trails. You cannot hide the logistics of a heavy industrial machine, so put the pieces together. The official story of mindless brute force is physically impossible. The alternative theory of secret mechanical machines is logistically impossible, which leaves only one explanation. The technology used to carve those tunnels was not a machine, and it was not brute force. It was a highly sophisticated, deeply refined human skill that has been completely erased from our collective memory. To understand what really happened in the dark, we have to look at the one piece of evidence the men in the offices never bothered to write down, but which the men in the tunnels lived and died by. We have to look at the lost art of reading the rock. These men were not swinging pickaxes at blank walls. That is the myth of the unskilled laborer. In reality, the men who led the work at the rock face were practical geologists. Before a single strike was made, they would stand in the flickering light of a candle and study the face of the granite. They were looking for the grain. Just like wood, solid rock has a grain, microfissures, fault lines, and planes of weakness created millions of years ago when the magma cooled. The masters of the tunnel knew that if you hit the rock against the grain, you could swing a sledgehammer for a month and achieve nothing. But if you found the exact plane of weakness, you could split a boulder the size of a house with a whisper of force. The perfectly parallel grooves we see in the surviving photographs were not made by a machine. They were made by a technique known as single jacking and double jacking. And once you understand how it worked, the genius of it takes your breath away. Imagine you are standing in the tunnel in 1882. The air is thick with stone dust. Two men approach the rock face. One man, the shaker, kneels in the mud. He places a hand-forged star drill, a heavy iron rod with a chisel tip, against a precise point on the stone. The second man, the steel driver, stands beside him, holding a heavy sledgehammer, often weighing up to 12 pounds. The driver swings the hammer in a massive arc, striking the head of the drill. Bang! In the fraction of a second between strikes, the shaker must twist the drill exactly 1/4 turn and wipe away the pulverized stone dust. Bang! He twists it again. Bang! Twist, bang! Twist. They did this in total darkness, by the light of a single candle. They did it at a rhythm of 60 strikes a minute. If the driver missed by half an inch, he would crush the shaker's hands into pulp. If the shaker did not turn the drill at the exact right angle, the bit would jam, the rhythm would break, and the progress would stop. This was not unskilled labor. It was a deadly, flawless choreography, a biological machine operating with the precision of a Swiss watch. They drilled hole after hole, 3 feet deep, spaced exactly inches apart along the fault line of the rock. And then came the most misunderstood part of the entire process: the black powder. We tend to think of explosives as chaotic, a massive boom that shatters everything in its path. But the men who handled the powder, known as the powder monkeys, did not use explosives to shatter the rock. They used it to slice it. Once the line of holes was drilled, they would carefully pack them with black powder. But they did not fill the holes completely. They left specific gaps of air. They understood the acoustic physics of a shock wave. When the powder detonated, the expanding gas would hit the air gap, turning the blast from a crushing blow into a sharp, expanding wedge. Because the holes were drilled perfectly parallel, the shock waves from the simultaneous explosions would meet each other inside the solid rock, creating a massive plane of tension. The rock had nowhere to go. It would simply detach, shearing off in one massive, flat sheet, leaving behind the smooth, half-cylinder scars of the drill holes. That is how you carve a perfectly geometric tunnel through a mountain without a machine. You do not overpower the mountain, you outsmart it. You use the geometry of the drill holes to guide the physics of the explosion, turning the rock's own hardness against it. Everything now points in one direction. The astonishing geometry of the tunnel walls, the impossible timelines, the lack of mechanical parts in the supply ledgers, they all agree. And the thing they agree on is the one thing the wealthy financiers of the 19th century never wanted to admit. The men covered in dirt at the bottom of the social ladder were actually highly advanced structural engineers, executing a complex symphony of geology, metallurgy, and acoustic physics. So, what actually happened to this knowledge? After everything we have seen, it is finally possible to say why this magnificent human achievement was reduced to a fairy tale of brute force. The answer is both tragic and profoundly revealing. This method was never magic, and it was never a mechanical secret. It was generational knowledge. It was refined over centuries in the deep tin mines of Cornwall, in the coal seams of Wales, in the quarries of China, and brought across the oceans by immigrants. It was taught by voice, by rhythm, and by the scars on a man's hands. It existed entirely in the muscle memory and the minds of the workers. And that is exactly why it was so fragile. Knowledge that lives in people, not in textbooks, dies with the people who carry it. The railroad companies had a deep financial incentive to classify this work as unskilled labor. If you admit that the men carving your tunnel possess a rare, highly technical skill that your entire empire depends on, you have to pay them for that skill. You have to treat them with the respect that their mastery demands. But if you write in the official ledgers that they are simply uneducated brutes swinging heavy sticks, you can pay them pennies a day. You can replace them when they fall, and you can claim the glory of the engineering triumph for the men in the suits who drew the lines on the map. The official history was not just an innocent oversimplification, it was a deliberate economic erasure. By the late 1890s and early 1900s, true, reliable pneumatic drills finally arrived on the scene. Powered by massive steam compressors located outside the tunnels, these heavy machines could drill holes faster without the need for the delicate, deadly dance of the double-jack teams. Modern dynamite replaced the nuanced acoustic blasting of black powder. The new machines did not need to read the grain of the rock, they just chewed through it. Within a single generation, the need for the human rock reader vanished. The older men retired or died of silicosis from the stone dust. The younger men were taught to operate valves on a pneumatic drill instead of feeling the resonance of a star bit. Because the knowledge of the shaker and the driver had never been written down in university textbooks, it simply evaporated. It stopped being a practice and started being a rumor, and finally faded into total silence. We cannot prove the name of the man who drilled the specific hole in the photograph. We cannot know the exact song he hummed to keep the rhythm of the hammer. At this distance in time, those intimate details are lost to the dark. But of every explanation ever offered for the impossible geometry of the 1880s tunnels, this is the only one that leaves nothing unaccounted for. The physical scars on the rock match the exact dimensions of a hand-turned steel bit. The sheared faces match the physics of directional black powder blasting. And that is the quiet weight of it. Not a lost secret hidden by some vanished alien race, and not a massive mechanical cover-up, just ordinary, staggering human brilliance. Powerful enough to cut through the spine of a continent, and fragile enough to be completely forgotten the moment a machine could do it cheaper. But the answer is not really where this story ends, because what it tells us about ourselves is the part that lingers. We live in an era where we automatically equate the word technology with machines, with electricity, with silicon and steel. We look back at the people of the 19th century, or the 12th century, or the ancient world, and we subconsciously view them as primitive simply because they did not have our tools. We assume that if they built something magnificent, they either must have suffered immensely through mindless, grueling agony, or someone else, something else, must have helped them. This story is absolute proof that we are wrong. Human skill, perfected over thousands of hours, synchronized flawlessly between two people in the dark, is a technology. A deep, tactile understanding of the earth you are standing on is a technology. Entire libraries of practical, genius-level engineering existed in the calloused hands of people whose names history did not bother to record. And it can happen to us just as easily as it happened to them. We like to think knowledge only moves forward. But these tunnels stand as silent monuments to the terrifying reality that an entire body of knowledge, capable of moving mountains, can vanish in the space of a single lifetime if we stop passing it on. Think back to that vintage photograph from the start, the men with the dust on their faces staring out of the glass plate negative. Look at it again now, in your mind. They are not mindless laborers holding primitive tools. They are the last masters of a dying art, standing inside a masterpiece they carved with their own hands, listening to the rhythm of a world that is about to replace them. So I want to ask you this: what is the modern equivalent? What deep, physical human skill or knowledge do you think we are quietly losing right now, simply because a machine or a computer can do it faster? Drop your answer in the comments. I genuinely want to know what you think, because the comments under these videos are half the reason I make them. And if this is the kind of story you want more of, the ones that look past the official records to find the reality hiding in plain sight, then consider subscribing. That is the only way you will catch the next investigation, and there are stranger ones waiting in the archives. If this journey into the dark kept you here to the end, leaving a like genuinely helps more people find the channel, and it is the reason we can keep digging into these forgotten corners of history. Thank you for staying with me all the way through. Keep questioning the things everyone else assumes are simple, and I will see you in the next one.